6 weeks ago, a machine learning model trained on thousands of Old Norse runic inscriptions produced a reading that its developers did not expect. The inscription in question had been sitting in a Scandinavian museum for decades, classified as a damaged and partially illegible fragment. When the model finished its pass, it flagged a sequence of characters that, if correct, would push documented Norse knowledge of lands west of Greenland back by roughly 500 years earlier than the consensus timeline. The researchers involved have been careful. They have not claimed a definitive translation, but they have published their process, released the model outputs, and invited the wider runology community to check their work. And what has followed has been, by the standards of this field, a quiet kind of earthquake. Let's back up and establish what we actually knew before this happened. The accepted story of Norse contact with North America is built primarily on two pillars. The first is the Icelandic sagas, specifically the saga of the Greenlanders and the saga of Eric the Red, which describe voyages led by Leif Erikson and others to a land they called Vinland, around the year 1000. The second is the archaeological site at Lanso Meadows, on the northern tip of Newfoundland, excavated starting in the 1960s by Helge Ingstad and Anne Stein Ingstad. Radiocarbon dating and subsequent refinements, including a 2021 study using solar storm markers in wood samples, have placed Norse activity at the site as early as the year 1021. That date, confirmed by an international team and published in Nature, is currently the earliest scientifically verified European presence in the Americas. The year 1021 is a real anchor. It sits in the scholarly record, and it has shaped how we understand the edge of the Viking world for the last 60 years. The question the new AI analysis raises is whether the written record might contain references to that edge from a significantly earlier period than anyone previously recognized. The inscription at the center of the reanalysis was originally catalogued in the late 19th century as part of a collection of weathered stones recovered from a burial mound in northern Scandinavia. The surface had been damaged by centuries of exposure and by earlier attempts to make rubbings of the carvings, which in some cases actually abraded the stone further. Several runologists had examined it over the years. Their readings varied. What they mostly agreed on was that the inscription was genuine, that it was composed in the Elder Futhark runic alphabet, and that parts of it referred to a journey and to something described with a word that had been read variously as a type of vessel, a place, or a personal name. It was that uncertainty, the sheer ambiguity of the text, that made it a natural candidate for machine learning analysis. The model involved was developed by a team working at the intersection of computational linguistics and historical archaeology. They had spent years compiling a training dataset from the Rundata corpus, which catalogs thousands of runic inscriptions from across the Norse world. The model learned to recognize character shapes under varying conditions of erosion, to infer missing glyphs based on contextual patterns, and to weight alternative readings by how well each one fit with the grammar and vocabulary of Old Norse as it was actually used. It was not, as some headlines have suggested, a translation machine. It was a probabilistic reader. It offered ranked hypotheses about what a given surface might once have said. When the team fed the damaged inscription into the model, the top-ranked output described a voyage west of what it called the Green Land, using terminology that, in its specific grammatical form, closely resembled phrasing found in later sagas. The model also flagged a series of glyphs in the damaged portion as matching, with high confidence, a word that in Old Norse refers to a densely wooded coast or forested shore. That word is significant. The sagas describe Vinland as a land of forests. One of the defining features of the Newfoundland area descriptions is the abundance of timber, something the Greenlanders themselves lacked and actively sought. A reference in an older inscription to a forested land reached by sailing west of Greenland would line up with the geography the sagas later describe in more detail. The real issue, though, is the dating. Based on a combination of linguistic features, including the specific rune forms used and the grammatical conventions of the text, the researchers estimate the inscription was likely carved somewhere in the early to mid-5th century, give or take a generation in either direction. That is roughly 500 years before Leif Erikson's documented voyage. If the dating holds and if the reading holds, the implications are significant. That's a lot of ifs. And that's where the skeptical counterweight has to come in. Because the history of runic interpretation is littered with dramatic readings that later turned out to be wrong. The Kensington runestone, allegedly discovered in Minnesota in 1898, was for a time argued to prove 14th century Norse presence in the American Midwest. The consensus today is that it is almost certainly a 19th century creation, probably carved by Scandinavian immigrants. The Vinland map, once hailed as a pre-Columbian document showing North America, has been analyzed repeatedly and is now widely considered a modern forgery based on chemical evidence in its ink. Every few decades, the Norse in America story attracts claims that don't survive sustained scrutiny. Professional runologists have learned to be cautious, very cautious. And a number of them have already voiced reservations about the new AI reading. The most detailed of those reservations come from established academic runologists in Scandinavia, whose concerns break down roughly as follows. First, the model's output depends heavily on its training data, and the rundata corpus, while extensive, has known gaps and known biases. A reading that seems grammatically plausible to a model trained on sagas could easily reflect the model's expectations rather than what the stone actually says. Second, the inscription is genuinely damaged, and there is a limit to what any reading, human or machine, can recover from surfaces that have lost significant material. Third, the specific dating estimate rests on comparisons with other inscriptions, whose own dates carry uncertainty ranges, and those uncertainties compound when chained together. Most importantly, the critics argue, an extraordinary claim requires something more than a probabilistic output. It requires independent verification by human specialists, ideally using multiple techniques. And it requires that the verified reading be contextualized within everything else we know about the period. The research team, to their credit, has not pushed back against these concerns. Their public statements have been notably measured. What they have said is roughly this: the AI-assisted reading is one interpretation among several. It is not meant to replace traditional runology. It is meant to provide a new tool for re-examining inscriptions that have been set aside as too damaged to work with. And the fact that the top-ranked output points towards something consistent with the sagas, produced by a model that had no way of knowing which answer would be historically convenient, is at least interesting enough to warrant a closer look? That closer look is already underway. Several institutions have requested high-resolution three-dimensional scans of the original stone. A multispectral imaging campaign is reportedly being scheduled. And a handful of independent runologists have begun their own analyses, working from the same source material but using traditional methods. Whatever the final verdict turns out to be, the process is unfolding in public with access to the data, which is arguably the most important thing that can be said about it. It's worth pausing to consider why this particular story has captured attention so widely. Part of the appeal is the sheer image of it: Viking ships carving through the North Atlantic. A carved stone, half-weathered, that has been sitting quietly in a museum for 150 years. A machine learning model, trained on data that didn't exist a decade ago, finding something that human eyes missed. There is a romance to that combination that is hard to resist. But there is also a deeper reason the story resonates. It touches on something we have been slowly learning across many fields. That earlier peoples were, in general, more mobile, more interconnected, and more ambitious than older historical narratives gave them credit for. The last 20 years of archaeology have quietly rewritten our understanding of who traveled where and when and how. Polynesian voyaging reached farther than mid-20th century scholarship assumed. Bronze Age trade networks stretched across larger distances than was once thought possible. Human migration out of Africa is increasingly understood as multiple waves rather than one. Against that backdrop, the possibility that some Norse knowledge of lands west of Greenland existed earlier than the sagas themselves, perhaps transmitted through oral tradition long before it was ever written, is not particularly radical. It may even be, in a quiet way, expected. That is not the same as saying the new reading is correct. The distinction matters. An extraordinary claim is not automatically true because it aligns with a general trend. It still has to be proved in its own right, on its own evidence. The AI output is a starting point for that process, not a conclusion. There are other threads that may help clarify the picture. Researchers working on ice core records and pollen analysis from certain sites in Newfoundland and Labrador have, in recent years, identified small anomalies in vegetation patterns and burned layers that might indicate transient human presence earlier than Lance O. Meadows. None of these findings on their own prove anything conclusive. They are suggestions of possibility rather than evidence of fact. But in combination with a written reference, if such a reference really exists, They could form a more coherent case for earlier Norse knowledge of the region. There is also genetic evidence to consider. Studies of Icelandic DNA, published over the last 2 decades, have found small but measurable traces of indigenous American ancestry in some Icelandic family lines, introduced centuries before Columbus. The dating of those introductions is approximate, but the existence of any such signal is consistent with contact, in some direction or another, earlier than the mainstream narrative suggests. None of this amounts to a decisive case. It amounts to a collection of threads that, taken together, are making researchers rethink the edges of the Norse world with more openness than they might have a generation ago. The honest summary of where things stand is this. An AI model, applied to a damaged runic inscription, has produced a reading that, if verified, would be significant. That reading has not been verified. It is in the process of being examined by specialists, using a range of methods. The traditional academic consensus, based on the sagas and the archaeology at Lanso Meadows, places Norse arrival in North America around the year 1000. The new reading, if it holds, would suggest that some form of knowledge about lands west of Greenland existed much earlier than that. Most runologists are cautious. A smaller number find the reading compelling enough to warrant serious follow-up. The stone itself, battered and quiet, is sitting in a museum in Scandinavia, waiting to be reread. Whatever the final answer turns out to be, the process of arriving at it is going to look different from anything that came before. Machine learning will not replace human expertise in this field, but it will increasingly work alongside it, finding patterns in noise that traditional methods overlook, flagging possibilities that deserve a second look, and occasionally pushing a long-accepted timeline back by a century or 5. It's also worth spending some time on what machine learning can and cannot do in this kind of work because the topic is easy to misunderstand. The model used in this case is not a translator in the conventional sense. It does not take in a stone and produce an English sentence. What it does is recognize patterns in the raw shapes of rune characters, compare those patterns against the large reference corpus, and offer probabilistic guesses about what each character is most likely to be. From there, it strings together those guesses into sequences that, again probabilistically, match grammatical and vocabulary patterns found in Old Norse texts. The final output is not a translation. It is a ranked set of hypotheses. That distinction matters because it affects how the output should be interpreted. A top-ranked hypothesis from a probabilistic model is a starting point for human investigation, not a verdict. The researchers behind the recent analysis seem to understand this clearly. Their published paper repeatedly emphasizes that the readings they report are candidate interpretations, requiring independent verification. Several mainstream science outlets covering the work have, less carefully, described the output as a decoding, which overstates what actually happened. This is a recurring issue in the wider conversation about AI and historical research. Machine learning has genuine value in these fields. It can process volumes of data that humans alone could not review. It can flag faint patterns that human readers might miss, particularly in degraded or damaged material. It can do so without the specific expectations that sometimes shape human readings of familiar texts. These are real advantages. They are also crucially different from the ability to produce a definitive answer. A model's output reflects its training data and its mathematical architecture. It does not know things. It generates probabilities. The interpretation of those probabilities remains a human responsibility. Specialists in computational approaches to ancient languages, including researchers at institutions like the DeepMind team that developed the Ithaca model for reading damaged Greek inscriptions, have been clear about this framing. AI in their field is a tool for collaboration, not replacement. A good reading emerges when a human expert works with model outputs, tests alternative hypotheses, checks consistency against external evidence, and uses the model's ranked suggestions as prompts for further investigation. In the case of the Norse inscription, that collaborative work is just beginning. Another dimension worth considering is what an earlier Norse awareness of North America, if such awareness did exist, might actually have looked like. The romantic version of the story, in which a 5th century Viking ship makes a direct crossing to the Newfoundland coast, is probably not what anyone is seriously proposing. Norse voyaging capabilities in the 5th century were considerably more limited than they became during the later Viking Age. Open ocean navigation across the North Atlantic required specific vessel designs, specific navigational knowledge, and specific motivations that developed over centuries. What earlier awareness might plausibly have looked like is something more like word-of-mouth knowledge. A recollection passed down orally of a coastline encountered during an unusually long drift voyage, or of stories heard from peoples living even further west in the Atlantic frontier. Such knowledge could easily predate the actual documented voyages by a considerable span, in the same way that stories of distant lands often precede formal exploration in many cultures. Seen that way, the possibility of an earlier inscription referencing lands west of Greenland is not a claim that 5th century Norse explorers reached the Americas. It is a more modest claim that, at some earlier point in Norse history, there may have existed some form of awareness of what lay at the far western edge of the Atlantic world. That distinction matters, and it is usually lost in the more sensational framings of the story. If the inscription is authentic and accurately dated and correctly read, all of which remain open questions, what it would tell us is that Norse cultural memory about the Western Ocean was deeper and longer than the written sagas alone suggest, which, given how oral traditions work in most cultures, would be consistent with what we already suspect about the relationship between sagas and the older material they preserve. There is a quieter beauty to this framing. It does not demand that the Vikings achieve feats beyond their historically documented capabilities. It simply suggests that their world was a little larger than we thought, a little more connected, a little more aware of the edges that surrounded it. That kind of revision, when it occurs, tends to deepen our appreciation of the past rather than shake our understanding of it. If you have ever walked past a display case in a museum, glanced at a damaged stone, and thought there wasn't much left to learn from it, this is a good moment to reconsider that assumption. Sometimes the answer is still there. It just took a new kind of reader to find it. The next few months will likely bring more information. Independent runologists are working. High-resolution scans are being processed. Peer review is underway. Whatever the verdict turns out to be, the methodology will be studied and refined and applied to other damaged inscriptions, of which there are many. And the long, slow process of rewriting and refining our understanding of the Norse world will continue one stone at a time, one reading at a time, one careful argument at a time. Whether or not this particular inscription turns out to contain the reference its discoverers believe they have found, the fact that we are even having this conversation rigorously and publicly and with data we can all examine is itself a small sign of how much the field has grown. Not long ago, a damaged stone in a quiet museum would have stayed quiet. Now it speaks just loud enough to be heard, and enough people are listening to make the listening matter. There is one more thread worth pulling on before we close out this story, and it involves how discoveries like this one get communicated to the public. When a research paper uses cautious, probabilistic language, and a press release simplifies that language, and a news article simplifies the press release further, and a social media summary compresses the news article into a headline, the result is often a claim that bears only a loose resemblance to what the researchers actually said. This is not a criticism of any individual journalist. It is a structural feature of how complicated findings move through the information ecosystem. Every step of simplification loses nuance. By the time the story reaches most readers, the hedged claim has often hardened into a definitive one. Researchers who work in areas like runology, where cautious framing is essential, tend to be acutely aware of this problem. Some have started releasing their work with accompanying plain language summaries that preserve the original hedging, or with video explanations in which they can walk through their actual conclusions at their own pace. These efforts help, but they do not fully counteract the pressure of a media environment that rewards strong claims over careful ones. Part of what this means for viewers and readers is that the best way to evaluate a story like this one is to try whenever possible to read the original researcher's own words rather than the third-hand summaries. The team behind the recent runic reanalysis has made their work publicly available. The primary paper is technical in places, but the discussion and conclusion sections are accessible, and they spell out exactly what the researchers are claiming and what they are not. Anyone seriously interested in the question would do well to spend some time there rather than relying on second-hand accounts. That kind of engagement, admittedly, is a lot to ask of casual readers. Most of us simply do not have the time or background to wade through specialist papers on Old Norse linguistics. What we can do, though, is hold the framings we encounter loosely, be skeptical of the strongest versions of any claim, and remember that the real state of knowledge is almost always more tentative than the headlines would suggest.